All right, so we're doing 16 microcomputers. This is another tree diagram. I really like tree diagrams. This one has 3 in the split. So if you read this problem, they give you this information right at the end, but they tell you that the chance of getting microchips is 40% C, 40% B, 20% A. Okay, and then I need to organize it this way. I need to sort of say, if it's from A, what's the chance of it being defective, right? So factory A, defective, kind of a lot, 20%, not so great. Factory B, defective is 10%. Factory C, defective is 0.05. Now, on the other hand, on the bottom here, we have non-defective. I'm going to call that good. So just to fill this out, that would be whatever the complement, the opposite of that number is, to add it up to 100%. So 80% good for A, 90% good for B, and 95% good for C. And if the question is not asking about the good ones, I get it, but this is not a complete sample space. It's everything that could possibly happen. Okay, so first question is asking us to find the chance of a defective microcomputer. So I am actually going to have to fill in this tree anyway to finish that. So to finish this, I am going to multiply along each branch. And I'm just going to focus on the defective ones because I know that's what the question is asking me. All right, turned out that wasn't so hard. Okay, so I multiply along the branches for the defective ones. So here's the chances of being defective and from factory A, being from factory B and being defective, and from factory C and being defective. So that's each one on its own. Now, first question was, what's the chance that you have a defective microcomputer in the shipment? It's going to be all of these guys added up. So we're going to say the probability of being defective is all of the different ways to do that combined. So probably being from factory A and defective, and the probability of being from factory B and defective. There's all the 3 different ways you might get something defective in your shipment. So all those combined. So that's a 0.04 plus 0.04 plus 0.02, which is 0.1. So 10% chance of defective microcomputer. So next up are the events microcomputer comes from factory A and microcomputer comes from factory B mutually exclusive. Mutually exclusive means you can't have both of them be true at the same time, and in this case they are. And you can see that because they're on different branches of the tree. So you can't have both of these happen at the same time. It's kind of the point of the branches. So let's go ahead and say, yes, being from factory A and B are mutually exclusive. They cannot both happen at the same time. One object cannot be from both of them, is what I mean. So this is a rare one, but we found one. Something is mutually exclusive. Now, heads up, if something is mutually exclusive, it's absolutely not possible to be independent. Being independent means that one has no effect on the other. If they're mutually exclusive, the moment I know that one of them happened, the other one can't happen. So that's the opposite of being independent. So not independent. If I know something came from factory A, it cannot be from factory B. The moment something's mutually exclusive, it cannot be independent. These two are 2 special cases of combo events, and they cannot overlap. All right, last one. Suppose the manager randomly selects one microcomputer and discovers that it is defective. What's the chance that it came from A? So the way to think about this is they're saying it's for sure defective. So I'm going to write this as, what's the chance it came from A given that it was definitely defective? And what that means is I'm not looking at the entire sample space, all 6 of these outcomes that are here. I'm only looking at the defective options. And we're looking at the chance of being defective and the chance of being defective and coming from A. So this is the probability of A and defective divided by the chance of being different. Okay, so So 40% chance that if something is defective, it came from A. And that's it for that one.